So this is my introduction to deriving the quadruple angle formula, and this is based on de Moivre's theorem or formula, of which Euler's formula, the cosine x plus I sine x equals e to the ix, is a special form. And as I'm German, I know how to pronounce Euler because he was from Switzerland and he spoke German, so it's Euler. French, I know a little bit. It's a little bit harder for words, for names like these here. So I looked it up. De Moivre. And I will try not to pronounce it too many times because even I have a hard time with that. So in any case, here's Euler's formula and here is de Moivre's. And we can see the relationship between the two. And the e to the ix, by the way, it resolves itself to the cosine x plus I sine x. And then when we throw in this factor here for the argument of the cosine and the sine, the n here, right there and there, and on the other side, it turns out into an exponent. So that is the theorem or formula by de Moivre, and that's what we're going to use. So the n here can take on any number, any positive integer number we want. And what we will find in the book are these double angle formulas. So when you have cosine 2x sine 2x, and you write it like this, so this is the left-hand side of the theorem, and this here would be the right-hand side of the theorem. And you see the square there. Well, we have a square, so we have this perfect square trinomial. So we resolve the square, there it is, on the right-hand side. And notice what happened with the I, with the imaginary number right there. The last one here is being squared, so it's going to be I squared, which of course is -1, and there's the negative in front of that. And we can see that. So the I is gone because it is an I squared. And by the way, this particular part we actually will use in a moment when we go to the triple angle formula. Then we rearrange these here, these three terms that cannot be combined, but rearrange them so that we have in the front the parts without imaginary parts, and in the back the one with the imaginary number. So in the front here we have cosine squared minus sine squared, which is not the Pythagorean theorem, okay? So they don't go away. Cosine squared minus sine squared, and that needs to be equal to cosine 2x, and that is what you will find in the textbook. And I acknowledge there are two other ways of expressing that, which I don't list here. And then for the sine 2x right here, well, it has the I in the front, just like here, it has the I in the front. But we say, okay, we don't need the I anymore, so the sine 2x that we have up here is going to come out to 2 cosine x sine x, and it's right there. So that's one way of coming up with the double angle formula. Okay, let's go to the triple angle formula. And I go through this one here to give you a good example as I'm asking you to do the quadruple one then. So here's the plugging in the 3 for the n. So cosine 3x plus I sine 3x. And then on the other side of de Moivre's theorem, we have cosine x plus I sine x to the third power. Okay, I mentioned earlier, keep this one in mind from second line to the third line, so perfect square trinomial, cosine squared plus 2i cosine sine minus sine squared, watch what happened here. Instead of just doing the cube here, I actually just did the square first, and there it is, there's the same one. But then of course I need to multiply it again with cosine plus I sine x. So in the front here we have a square, here we have times another one, that's the original cube that I have in the second line. Okay, then I multiply this all out, and I pay attention to what happens with the i's when I multiply them. So here, this one is easy then, cosine squared times cosine, that's cosine cubed. Then I have 2i cosine sine times the cosine, and then I have sine squared times the cosine, and I do the same thing with the I here. So cosine squared times I sine is this one here. And then the tricky part, of course, is this one right here. Multiply that by I sine x, And I have, again, I squared, which will give me a -1, and there it is right there, the -1. And then the last one is I minus I sine cube. And then, again, rearrange, whoops, I highlighted too much, rearrange these here with the real parts in the front and the imaginary parts in the back. So I get this one here, and that then there would be, therefore, the cosine 3x. These are, because the cosine 3x here has just a real part. So that's this one here. And then I have the I sine 3x, which is all this one here that also has the I in the front. And again, I can write it like this. And I think, let's see, one moment. And I'm back after I reviewed this one moment here for a minute or so. And I noticed that going from this line to this line, I have one of these too many. So I better take that out. There we go. There's only one 3i cosine squared sine x. So this one here, this part here, with the I in there, is the same as this one with the I. But then when I write it down, I don't need those anymore, and there it is. So that's how the triple angle formula is derived. By the way, these are alternative ways of writing them. So for you, it's now the turn to derive the formulas for 4x, cosine 4x, sine 4x, which then, of course, would read, cosine 4x plus I sine 4x equals, in parentheses, cosine x plus I sine x, close the parentheses, to the 4th power. And I would recommend that do this one here twice, the perfect square trinomial, once for square, and then again for square because it's to the 4th power. And then you have to multiply it out, and of course it gets a little longer, and pay attention to what happens to the i's and the I squareds and so on. And then do pretty much the same thing that I did throughout here.